The overall goal of this project is to be able to build a machine learning model that is able to predict an individual's annual income if it exceeds $50,000. And so far, we have been able to cover major stages in this machine learning pipeline, which includes dataset exploration, dataset cleaning, exploratory data analysis, and now pre-processing. Now, all of these stages are not just for the sake of it. It's like building a house. You need a very solid foundation for it, right? So we're simply trying to build a really strong and solid foundation for our model. If the foundation of your house is shaky, there's no way that house is going to last long, right? We don't want that with our model. Now we are right at pre-processing. And what is pre-processing all about? Pre-processing is all about transforming our data set from a human readable format to a machine learning algorithm readable format. But then it is way beyond just converting it to a readable format, right? It is about optimizing the data basically. It includes cleaning the data, making sure it is properly structured, and also making sure that it is in a numerical form, because this is the only way that our algorithms are going to be able to properly understand and learn from this data. So before we dig into our preprocessing, I'll be introducing the libraries and the modules that we'll be using for our preprocessing. Now I have already introduced the standard libraries and those for visualization. Next is the import for preprocessing and pipelines, and also for model selection. So the library that we're going to be using is scikit-learn, also known as sklearn, right? This is a Python library that serves as a one-stop library for everything machine learning, right? Because it offers tools for machine learning, pre-processing, model building, and even evaluation of these models. So it's really like our one-stop toolkit for everything regarding machine learning basically. So yes, here are some of the modules from it that we'll be using from, and then here are the classes and transformers basically that we'll be making use of, right? Also, we're making use of train test splits from our model selection module. So let's get right into it. So getting right into our preprocessing, right? Like I said, it's about cleaning our data, making sure it is structured and everything is in a numerical form, right? So we're going to be focusing more on making sure that it is in a great structure and everything is in a numerical form, because we have already cleaned our data during our data set cleaning, right? So now let's get right into it. The data set that we had, that's our data frame, after our exploratory data analysis, we had extra columns that I had created, right, for my visualization, which includes 𝐻𝐶𝐴 and age group. I'm not going to be needing that for that pre-processing really, right, or for my model development, because it's simply going to be like redundancy, a repetition. I already have the H column here, I already have 𝐻𝐶𝐴 and 𝐻𝐶 right? Sorry, capital gain and capital loss. So I don't need this. If I use this is going to cause multicollinearity, and it can also cause overfitting, right? It's going to serve as a lot of noise. So I don't need that. I would have to be dropping that. Also, another column that I'll be dropping is education norm. And why am I dropping this column? From our dataset exploration, realized that these columns, education norm and education, are two separate columns, but they represent the same thing. Education norm is simply the numerical hierarchy of education. And if you remember from dataset cleaning, I was able to reduce the cardinality, right, under the column education. I was able to group some educational columns categories together to reduce the number of categories, and using this is actually going to serve my model better. It will help it generalize better. So I decided to proceed with education and drop education norm. Again, I don't want repetition, right? So I created a variable here with the list of columns that I want to drop, and then I went ahead and I dropped these columns. Then my new data set, now I reassigned it to a new variable, which is df model. Why am I doing this? It's simply like a best practice basically, and also going forward, if I encounter any issues or I make any irreversible mistakes on my data frame, I can simply come back here to the data set I used in my exploratory data analysis and make a new column. So yeah, and then I simply printed out the new list of column names to make sure that the ones I have on ground are the ones that I need for my model. So everything looks good. The next thing I did was to pre-process a particular column or feature, which is the sex column. The sex column has only two categories, which is male and female. And I just need like one step to do all the pre-processing that it needs, right? I could just leave it and pre-process it alongside the other categorical features, but I decided to just handle it on its own. So I replaced all the males with 0 and replaced all the females with 1, and I am done with this. I simply came here to check the unique values, and we can see sex only has 0 and 1, which is great. Here I simply stated out the columns that I dropped and why I dropped them. If you remember, final weight, we dropped it right at dataset cleaning. So now let's get into the pipeline. So preparing for our pipeline, the very first thing I did was to separate my features from my target. Now, what are the features? The features are the independent variables. And what are they? This include every other column in my data set except the income column. So every other column is the input. These are the columns that predict my target, and the target is the income, because the income is the class that we're trying to predict from, right? So every other column minus the income, they are the independent variables and they are the features. So now whenever I say features, you know what I mean. And whenever I say target or label, I am referring to the income column, right? So now what we are doing here is that we're assigning all of our features to X, and we're assigning our target or our label to Y. This is the standard practice for our machine learning, right? After this, I went on to get straight into my preprocessing, right? What I did was, now for the features, I have both categorical and numerical features, right? So I separated them because I have preprocessing techniques that are specific to numerical columns and those that are specific to categorical columns. So that is what I did here. I made a list of the categorical columns and I made a list of the numerical columns. For the numerical columns, I took my time to define or to state out the columns. Why? Because if I had used a method like the one for the categorical columns, it is simply going to include the sex feature, right, to the numerical features or the numerical columns. But if you remember, we are done preprocessing our sex feature. So that is what I did here, right? Now, we need to know that there are some standard preprocessing steps, right, for certain type of features. Now, one of the standard preprocessing steps, for our categorical feature is converting these strings or the categorical features to numbers, right? And there are different ways of doing this, but what we're going to be using is one-hot encoding, right? One-hot encoding has a special technique whereby every category in a column, it converts it into a binary column, right? I'm not going deep into that, but one-hot encoding simply helps us to convert all our categorical columns or features into numbers, right? So that's one of the standard preprocessing steps or techniques. And then one of the standard steps too for our numerical columns is scaling, right? And for this, we're going to be standardizing it, so we'll be using standard scalar. Now, why are we doing this? Scaling simply helps to make sure that all of the features in our numerical columns have the same scale, right? Because these columns actually have different scales, and if we use it like that in training our models, there will be a bias, right? Because those ones that have greater scales, the model will be biased towards them. It will be as if they have more influence on our target, which is not true. So scaling them is really important, especially also for some algorithms like SVM and logistic regression and others that are very sensitive to feature magnitude. But again, preprocessing is not a one-size-fits-all, right? The nature of your data set actually determine the preprocessing steps that you take. So here I have some custom preprocessing steps or transformation that I'll be doing depending on the type of data set that I have. Now, if you remember our capital gain and capital loss, right from our dataset exploration, we already saw that there was great, it was highly right skewed, right? Most of the values in these columns are zeros. And for those that are not zeros, their values are like high, right? They're extreme values. And then if we use it like that in our model, it's also going to cause a bias, right? It's going to be more favorable to the extreme values. So now what I did here was I created a function, right, to use the log transform. Basically, I created a function using log transform so that I would be able to, what exactly this does is that it sort of compresses the extreme values, right, the very large values. It compresses them and it brings them closer, and now it does not affect the order of these columns. So that's what I did. I also used the log1p instead of the regular log because log1p handles the zeros in my data set better, because with the regular log, the log of 0 is undefined, but the log1p of 0 is 0. So this handles it great for me. I created another function, right, to cap my hours per week, because we had outliers, and I did not want these outliers to affect my data set. So I created this function here to handle that. So far, if you notice, I made good use of functions and loops, also the pipeline that we're going to see now. Why? I really prioritized this because I wanted my code, or my work basically, I wanted to have a clean code. I also wanted to have a code that is reusable and reproducible. So this is like one of the reasons why I did most of the things I did. So now I created a pipeline here for my numerical columns. Here I created a pipeline, right, which includes my log transform and cap. So what I'm simply saying here is that do this, right, and I'm using my function transformer for these two functions because this is the only way that I can be able to use these functions inside of a pipeline. So what pipelines do is that they're able to help you arrange your transformers or your preprocessing steps, right, in a format whereby, you know, the preprocessing happens one after the other. Because if I'm to do this preprocessing manually or on my own, I will have to preprocess the categorical difference, the numerical difference, reassign them back to new variables, because each transformer, you know, in preprocessing gives me like a new set of data set basically. So I would have to do that, reassign it to new variables, then later on go and concatenate them. And there's room for error in this, but pipelines just help me be able to like wrap all my preprocessing stage in one place. So here I have a pipeline for my numerical processing. I clearly stated out the steps that I should take. It should perform log transform, it should cap my hours, and then it should scale all my numerical features, right? Then I came here to create. And then yeah, next, so I simply created an instance here for my one hot encoder, right? Because that's what I'll be using to preprocess or to transform my categorical columns basically. So now I am combining my numerical pipeline and my categorical pipeline, right? But this is really not a pipeline because it's just one step, yes, for transforming my categorical features basically. So I'm using a column transformer because using a column transformer, right, I can use transformers for different type of columns, right? So it applies them like in parallel. So the transformation from numerical columns is happening, the transformation for categorical columns is also happening, and when this is done, it still has everything together in one place. So that's basically what is happening here. And if you see, what I did here was numerical columns here. When I defined it earlier on, right, sex was not included there, so I made sure that I included this remainder equals to pass through here to make sure that my sex is included in the data set. So now I have my full pipeline here, and my full pipeline simply is this preprocessor, right, where I have combined the preprocessing steps for my numerical features and my categorical features. Now, something that is really important to note is that up until this point, right, all we have done is to define the changes that we want or how we want to transform our data set, right? But no transformation has actually happened unless we apply the .fit and the .transform methods, right? But before that, we have to separate our data into the training set and the test set. So this is what we've done here. We separated our data into the training set and the test set, right? Having the test set size at 20%, and we have a random state of 42. Now this is where our preprocessing happens really, and it's really important to note that this whole pipeline, right, that I have, I am fitting all the transformations, right? I am fitting them to my X train, to the set that I want to train my model on. So I am fitting it to the X train and also transforming it. But for the X test, I am only transforming it because I don't want to cause data leakage. Remember, the training set is used to train the models, and the test set is used to test how good the model is. So we do not want our model, right? And we do not want these transformations basically to be learning from our test set, right? And then finally, what I am doing here is like a sanity check basically, making sure that the size of my, so I'm making sure that the number of samples for all of my test sets are the same, and the number of samples for all of my training sets are the same. That is what I'm doing here. And right before that, what I did was simply to print out the new shape of my training set and my test set, and what we can see clearly here is that the number of columns or the features have increased. Remember, at the very beginning we had about, I think, 13 or 14 columns, but now we have like 47 columns. Why? Is because of all the transformation that has happened, right? Especially with one hot encoding, like I mentioned earlier, it really creates like new binary columns for each categories under our categorical features. So what I have here is simply a summary of everything that I did in my preprocessing and why I did it. And then next we're going to be going right into our model development.